All right, today we're going to talk about the perpendicular bisector theorem and the angle bisector theorem. The perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So in this picture, the red line is going to represent a perpendicular bisector. That means that these two segments are equal, and this is a right angle. So it's a perpendicular bisector. So what this theorem is saying is if any point is on the perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment. So that means if I pick this point right here, that means the distance from there to there is equal to the distance from there to there. Okay? And the theorem is saying it doesn't matter where you pick that point. I could pick this point right here. So this distance from here to there is equal to the distance from there to there. Okay? No matter where the point is at, if it's on the perpendicular bisector of a segment, then it's going to be equidistant from the endpoints of the segment. So what does that make that triangle up there, the top one, let me trace it. What kind of triangle is that then? It's isosceles. Okay? And this is the perpendicular bisector of the base. That means it's the what to the vertex angle? Well, kind of. That's not what it's called when it's doing it to an angle.
Angle bisector?
It's the angle bisector. Yep, it's the angle bisector. That means these two angles have to be equal. Okay? So if it's a perpendicular bisector to the base, if these sides are equal and this is 90 degrees, then that's going to make these two angles equal. Okay? So a lot of information comes out of this one theorem, doesn't it? We know just about everything we want to know about these triangles now, don't we? In fact, we know everything. These angles are both 90, and these are equal, so that means these two have to be equal, right? Remember the rule that says if two angles of a triangle are congruent to two angles of another triangle, then the third angles have to be equal? Right? Let's say our two angles are 30 and 50. Well, they add up to what? 80. So the third angle has to be 100. Well, in another triangle, the 30 and 50, the third angle would have to be 100. Okay? So they have to be. All right, let me clean this up. At least I didn't have to record that. And let's look at the second one here. The converse of the perpendicular bisector theorem. I'll pause, let you copy that down, and we'll talk. Okay, the converse of the perpendicular bisector theorem says if a point is equidistant from the endpoints of a segment, then the point is on the perpendicular bisector of the segment. So this is going the other way. This is saying if I know that these distances are equal, then that means this point is on the perpendicular bisector of this segment. Okay? It means it's on the perpendicular bisector of the segment. Now we have to be a little bit careful there. Is this red line, is that red line the perpendicular bisector of that? No. So this theorem is not saying that this red line is a perpendicular bisector to this the blue line here, the base. Whoops, I forgot I was in the wrong mode. We didn't say that the red line is perpendicular bisector. We said this point is on the perpendicular bisector. That means that there's a point here, I'm sorry, there's a line here somewhere that is the perpendicular bisector to this blue line that has to pass through that point. Okay? So just be careful. It's not the answer to every problem in the world, but it does tell us that if these distances are equal, then this point is on the perpendicular bisector. There could be multiple line segments drawn here. That doesn't mean they're all perpendicular bisectors. It just means this point is on the line. That if when we draw that line, it would have to go through that point. That's the key. Maybe that's the way I should say it. When we draw the perpendicular bisector, it has to go through that point. Okay? Is anybody confused on that? All right, moving on then. The distance from a point, this is really important. The distance from a point to a line is the length of the perpendicular to the line. Okay? The distance from a point to a line is the length of the perpendicular to the line. If I have this point, and if I have this line, okay, and I want to find the distance from that line. When I used to use a whiteboard, and it was actually, well, I'm sorry, I was in a different room. The other room was set up just like this. The door and everything's exactly in the same place, so sometimes I forget which room I'm in. So anyway, when I was in the other room and I had a whiteboard instead of a smartboard, I'd have kids come up and measure the distance from this point to the line. Well, I'd have you do that today, except it wouldn't record very well, so I'm going to go ahead and talk through what other students before you would have done, okay? And so they would take the ruler and they would come up here, let me undo that, and they would bring it up here and they'd measure like this, and one kid would say, well, that's 5. They'd draw that line, they'd say that's 5, and someone else would come up here and say, no, it's this line here, and they'd measure that to be 7. And someone else would come up and they would place this somewhere else. Sorry. And they would measure and they would get a different number. Okay? Well, so that we don't have all this confusion, it's kind of like solving an equation. We kind of have rules we have to follow, don't we? It's like simplifying an expression. We have the order of operations we have to follow, right? So that we don't all get a different answer. Well, the rule for this is what I just had you copy down, that the distance from a point, and so from this point, the distance from there to the line must be perpendicular. And so that means I have to find the perpendicular, which means I should measure with the protractor So now I have a perpendicular line. Okay? That's 90 degrees. If I measure this, I don't know if I can draw on this or not. No. Yeah, sorry, it won't let me draw. So that line there is my perpendicular. So that's what the measurement is going to be. Guess I didn't have to pull that out of there. So 4.7 if we use this top one here. If we go inches, it'd be 1 7/8. Okay? And so that's what this is saying. Okay? So all of our rules, like order of operations and solving equations, we have a rule here also that says to measure the distance from a point to a line, it has to be the length of that perpendicular bisector. I'm sorry, of that perpendicular. Okay? The perpendicular. So where would I use this? Well, if I wanted to make sure my driveway was as short as possible, because I was too cheap and didn't want to pay for gravel, okay? That's kind of why I have potholes in my driveway right now. But anyway, if I wanted to have the least amount of gravel, then I would want to make sure my driveway was perpendicular to the road and went straight to my garage. Okay? That'd be the shortest driveway possible.
You can make it really narrow.
What's that?
Or you can make it really narrow.
I could make it really narrow, yes.
Yeah.
The angle bisector theorem.
Right.
The angle bisector theorem, guys, says that if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. I'm gonna pause so you can copy this down. Okay, so here we have an angle, this black angle, and this red ray is the the angle bisector. This says if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. And so what that's saying is, if I just pick a point and put it on the angle, then this distance here is equal to this distance here. Now, remember, to measure the distance from a point to a line, it has to be what?
Perpendicular.
So that means I have to be saying these are perpendiculars. Okay? So those distances have to be equal if this point is on perpendicular bisector. Okay? Now, that seems really simple, right? Very straightforward. Here's the problem. All of a sudden they say, well, this is 3x plus 7, and this is 5x minus 5. And they want you to find x. So how do I apply this rule to that? Yeah.
Set them equal to each other.
Oh, I'm sorry. First of all, they do this. What does this mean?
Oh, it's bisector.
That means the red line is the angle bisector, right? And so you're saying that I say 3x plus 7 is
Equals 5x minus 5.
is equal to 5x minus 5. So let's try that. 3x minus 7 equals 5x minus 5.
It's plus 7.
Oh, plus 7. Sorry, my bad. I got too big of a marker there. So 3x plus 7 is equal to 5x minus 5. Okay? So how do I solve that? Doesn't matter. I usually try to get my x's together first. So I'm going to subtract 3x from both sides. And so I get 7 equals 2x minus 5. And I heard someone say, let's add 5 to both sides. And that would have worked. And so we get 12 equals 2x. So x is equal to 6. So then if they had labeled these like A, B, C, D, and they said find the length of DC, then we could go back now that we know what X is and find it, right? So my only point of that question is that you realize sometimes finding the value of the variable is the only way to find the answer, but it's not the answer. Meaning they're not asking you to find the variable, Eli, they're asking you to find something else, and you have to just find that so that you can move on to find the rest of it. Okay? So any questions on that? Alright, so we have another theorem here. It says the converse of the angle bisector theorem. And again, I'll pause this so you can copy that down. Alright, if a point is in the interior of an angle, so we have this point right here, point, and we'll just label it D, that's what we called it before. If this point is in the interior of the angle, is equal distance from the sides of the angle. So we've identified that these distances are equal and that it's perpendicular, so it's actually measuring the distance from this side and this side, okay? And so if that's true, then that means that red line, which connects that point with the vertex of the angle, has to be the angle bisector. So if this is true here, if these are equal and perpendicular, then that point is on the angle bisector, means that these two angles have to be equal. Okay? And so they might then turn around and say, this is x plus 2 and this is 3x minus 7. I didn't give us such a nice number now. Let's say, let's say 70. Just add a 0 to the end.
70?
Yeah, we'll see what works. Maybe that won't work out either. All right. So anyway, if this top one is x plus 2 and the bottom one is 3x minus 70, what this converse of this angle bisector theorem says is since these are equal, that means this point is on the angle bisector. So that means these two angles have to be equal. So 3x minus 70 has to equal x plus 2. So if I subtract x from both sides, I get 2x minus 70 is equal to 2. And if I add 70 to both sides, 2x is equal to 72. Divide, x is equal to 36. And 36 plus 2 is? If you test it, somebody on the test did something like this. They tested their answer, and they got, this is not what this is, but they got something like 54 and 40. Shouldn't have that been a hint that you made a mistake somewhere? You started out by telling me those two things had to be equal, and then you got two numbers that weren't equal. So somewhere there you should have said, oh, wait a minute, I must have made a mistake. Okay? This was not 54 and 40 in this case. It was 36 plus 2 is 38. And 36 times 3 is 108. 108 minus 70 is 38. So we got 38 both times. Okay? All right. Any questions on those 4 rules I gave you today? Not you, RJ? No questions? Okay. In that case, let's look at our calendar again. And again, I didn't have time for Diana to enter these assignments into your calendar. So that's why I'm showing you this calendar. But I should have time today. So today we're doing 3 to 66 by 3s. It's only 22 problems. Okay. Again, reminder, checkpoint quiz tomorrow. Your only quiz of the chapter is on next Tuesday. and your test is gonna be next Friday. On Wednesday, it's a short assignment, so I'll probably give you your practice test also on Wednesday. So when you finish your assignment, you can go ahead and get started on the practice test. Then on Thursday, you'll have more time to ask questions in class. Okay? This is what your calendar will look like when I get this stuff switched over. All right? So get to work today.